Hello, everyone. My name is Chelsea, and I'm a volunteer for the Dementia Society. Thank you, everyone, for tuning in. Today, our webinar is on research in cognitive decline, and it is done in collaboration with the Bruyère Research Institute. We have three speakers today, Dr. Frank Knoefel, Dr. Neil Thomas, and Dr. Andrew Frank. We will start shortly while we wait for participants to log on. This is a 45-minute presentation and is going to be followed by a Q&A period. So if you have any questions, you can type it in the Q&A box or the chat box, and the Q&A will be done at the end. Closed captions are enabled on this webinar, and you can turn them on by clicking the CC icon in the bottom menu of your screen. And I will pass it off to Herman.
All right, so welcome everyone. So my name is Herman Chica Alfonso, and I'm the education coordinator for the Dementia Society of Ottawa and Renfrew County. So research is essential to finding better ways to understand, prevent, diagnose, and treat dementia. For us at the Dementia Society, research is hope. So this live webinar, hosted in partnership with Bruyère Research Institute, will help us to understand current research in cognitive decline. We are very lucky to have three speakers, and our first speaker is Dr. Frank Knoefel. He is a physician at Bruyère Memory Program, also holds the chair of primary healthcare dementia research at Bruyère Research Institute. He's also a scientist at HWell National Center of Excellence Network and professor at both the University of Ottawa and Carleton University. Dr. Knoefel will talk about how using computers can help with diagnosing and monitoring cognitive decline and the impacts of aging and cognitive decline on driving. So without further ado, I will turn over to Dr. Knoefel.
Thank you, Herman. Thank you for that kind introduction, and good evening, everyone. And so I will see, yes, I have control of the slides, so that's a good thing. So the research we do at the Bruyère Research Institute here, and we're going to highlight some of it this evening, but essentially it can be divided sort of into two main categories. The first is what I would call technology and aging, and the second is research in drugs and therapeutic trials. And so I'm going to start us off by talking about some of the technology and aging research. And that technology and aging research can be further divided into what I would call smart home research, so technology that can be embedded into the home, and research on driving. So we'll start off with, so the first thing is we're going to talk a little bit about the AgeWell National Innovation Hub, SAM3. And because we owe a lot of gratitude and funding to AgeWell. So AgeWell is a national centers of excellence, and we've been participating with them since before 2015. The first grant, though, came in at 2015 for 35 million, and this is for the whole country. And there was another 22 million added in 2021, as you can see. And we were involved in the initial application, and as you can see, myself here and Dr. Bruyère were the first two principal investigators, and a lot of other people have joined, including Dr. Thomas and Dr. Sleistrup and others. So AgeWell is concerned about supportive homes and cognition and mobility, and those are the domains that we're most part of. So I want to talk about the first set of projects that we started, and this was actually in partnership with the Dementia Society. We actually went to the Dementia Society and we asked, this was about 6-7 years ago now, we asked, what is one of the biggest concerns you have right now in caring for people with dementia here in Ottawa? And the person we talked to said, look, My husband suffers from dementia, and at night, sometimes he'll get up to go to the bathroom, and that worries me because I don't know if he's going to find his way back to the bedroom, and especially in winter, I don't know if he's going to head outside. So I'm wide awake all night waiting for him to come back to bed. And so can you design some technology around that? And the kinds of questions you need to ask when you're sort of designing a system for nighttime monitoring are, do you want a wearable device, which is something that then you have to put on, but then when it's on, it's very precise and tracking the person? Or do you want an ambient device, so something embedded into the home? And we decided that we didn't want to rely on the person necessarily remembering to put something on or having to put something on that the person couldn't remove. So we went with the ambient sensors, the sensors that are embedded in the home. And we went that there was already sensors that people have in the home, and that's a security system, right? So you can get sensors as part of a security system that looks for motion when you're away from home. Now, you can also, of course, teach the system some new tricks, and that is to detect motion at night. And where is the person with the dementia? There are issues then that you need to do research on, which is where does the data go, and how do you store the data, and how do you use the data? And of course, there are real issues with how will the person living with dementia, as well as the care partners, accept new technology? Can you do it in the home? So we did that. And so here are the bits and pieces that we installed in people's homes. So this is a Sonos speaker. This is the sensors that were actually attached in the home. So you'd have motion sensors like this one here that would potentially be in a bathroom, this one that could be in a bedroom, this one would be in the hallway, and then a smart light or a light connected to a smart plug. And so you need a hub which connects to the internet, and then you install the bits and pieces. So a sensor on the door, a sensor under the bed, then you have the inside hub connecting to the internet. So essentially, we were able to detect the person getting out of bed. There would be a door sensor to say, did they leave the room, or which room did they go into? And then a speaker that could be used to tell the person living with dementia to go, please go back to bed because it's the middle of the night. So that kind of system we also installed into a retirement home, because it's one thing to be able to monitor people at home. It's a whole other kind of exercise to monitor people in a communal setting. So we partnered with a company called Esprit AI, who had a very similar set of sensors. So a motion sensor, a door sensor, and you see here, they're pretty small compared to a Toonie. And so Richmond Care Home in Richmond has 14 beds, and they have a complete female resident complement, and they all live with dementia. And so we wanted to test the technology that works very well in individual people's homes. We wanted to see how can you use that in a retirement home setting. And particularly, we were wondering about wandering patterns, time in bed, resting time. Can you monitor these, and what can you do with that information? So we ended up having in this group 7 higher functioning and 5 lower functioning ladies. Whoops, you got magic. It's appearing and disappearing by itself. Okay, and we had 407 nights of data, because the technology does all the data collection. Now once it's installed, it just runs and collects data. So we looked at rest time in the lower functioning and the higher functioning, and you see that's quite similar. And you can see that though that the in-room movements were very different. So the higher functioning group got out more times out of bed than the lower functioning group. And the time that they spent out of bed was higher as well. So you can see there's different patterns of behavior in the lower and higher functioning group. So that's just proving that that kind of technology can do that kind of monitoring. And of course, with the idea that you can improve sleep quality and adjust medication and that kind of thing, and then be able to see, have we made the right impact? So we also took this set of sensors into a hospital setting. So Greystone is a facility, it's a transitional care unit. It's actually the largest in Ontario. It has 120 beds, just over 120 beds. And it's a complicated partnership between Bruyère Continuing Care, Bayshore Health, and Greystone Village. And so what we wanted to do here is we wanted to see what is the best way of implementing technology. So it's one thing to have it technology that works. It's another thing to test it in people's homes. It's another thing to test it in an environment that's complex, like a hospital environment. So we had physicians, engineers, industrial designers that were looking at care processes, and then even business people that were interested in, can you cost effectively implement this kind of thing? And so it's a complex environment, it's in a complex process. So we had to have a large steering committee and a smaller implementation committee. And we did nighttime workflow mapping. So we actually had a student who spent a number of nights in the retirement, well, in the hospital setting, in the Greystone facility, tracking what the staff did at night. Then we had to select the technology and figure out what we wanted to do with it. And we've been asking the staff for feedback on how all this works. So that's some of the smart home technology, and Dr. Thomas is going to talk more about that shortly. But I also wanted to talk about driving simulation. And the first thing is, why are we even worried about driving simulation? The first, of course, is that driving is very important in Canada, and we need our driver's license to be independent, and we need our independence to stay physically healthy, to be able to go out to a gym and to go to a walk in the forest and that kind of thing, to meet with people, so to be socially engaged. And all of these things, of course, are good for our overall well-being. So unfortunately, though, as we age, and in particular as people have increasing cognitive impairment, driving becomes a greater risk. So right now, the way we assess driving risk is through a history and a physical, and we use paper and pencil tools. And here I've got two of the types of tests that are really important for understanding how a person's brain works. So here's someone who's drawing a clock, and you can see they had a little bit of difficulty distributing the numbers, and they went to 13. The 12 is not on top. So there's a number of mistakes here. And of course, the hands don't really, we can't really tell what time it is with these hands because it sort of runs through a whole bunch of numbers. So the clock drawing gives us an idea of how the brain is working. The other test here is the Trails B, and how it works is you connect a number to a letter. So 1A, 2, then B, then 3, then C, and so on. And so we do these, and we make a determination about safety to drive. And that's a very difficult conversation to have with patients and family members. And in particular, they have difficulty sort of translating the difficulty in these tests with a difficulty to drive. And so that's one of the main reasons we've invested in a driving simulator. The other issues are that on-road driving tests are actually expensive. They cost around $800 to do. And the good news about a driving simulator is if you do have a crash, no one gets hurt, right? There's no injuries to anyone, and then you can have the driving experience in a safe environment. And it is actually easier to do research on driving simulators because, of course, you'd have to be in the car with everyone driving and writing notes, and then your notes aren't that precise, and You know, if you don't look to the speedometer at the right time, you might not catch the right speed, whereas a driving simulator, it collects all of this data continuously. So it allows you in an easier way to monitor all the variables of driving. And so before we go and show you the driving simulator that we have, I just wanted to highlight how difficult this whole conversation about the driving assessment is. So what we actually did, we did a small research project where we asked family members of people living with dementia who had lost their license between 18 months and 3 years before the time of the research. And we asked them to tell us about, you know, how their experience was, going to an appointment, having a memory assessment and seeing the physician and then being told that, you know, driving was a risk. And so I just took 2 little quotes, but it gives you an idea of the importance of driving and the emotional content associated with it. So this is a daughter talking about her mom, and she said, well, she was frustrated and quite upset because she didn't see any reason for it. She did not see the risk that she was taking. So here's a daughter who, you know, who saw that her mother wasn't able to understand her challenges. And even though she failed on certain paper tests, that just didn't resonate with her. And here's the second one. This is a wife after the experience of her husband finding out that he couldn't drive anymore. But she's talking about her own lived experience. So she said, it was a shock for me. We weren't prepared. I was shocked by that decision right then and there. I didn't see it coming. And then I had to deal with his feelings. I couldn't see what our future was going to be. I was just trying to take care of him, and he was so angry. And I couldn't see the next week in the calendar. I was just living in that moment, and the moment was awful. So this is why driving research is so important, because it's such an emotional field and so important for people. So this is the machine that we have been able to get through a grant. And this is actually our machine. And this is one of our researchers driving. And so you can see that it actually, the cabin is taken out of a Cobalt, a Pontiac Cobalt. So it's an actual steering wheel, and the seat and everything, the gear shift, everything is exactly like it would be in a car, except that, of course, there's 3 computer screens replacing the outside environment, but there's a little mirror, and there's even a place to shoulder check. And so you can see how you can fade out different screens, so you can set up the environment for the person driving in many different ways. So our first project that we're going to be starting very soon is getting normative data. Normative data means we need to find out how people react to this machine that are healthy. And we want it at all kinds of different ages. So if it's difficult to keep the car in the middle of the road for everyone, then we wouldn't consider that, you know, to be particularly a sign of abnormality. But if healthy people can keep the car in the center of the lane, and then people with cognitive impairment seem to drift more, well, then that gives us something to measure in future research. So we need to get that baseline data first. The second project that we're going to be starting, oh, sorry about that, that should be a D, of course, second project, is in partnership with the Heart Institute. So the question we're going to be looking at is, what is the impact of chronic arrhythmia on cognition and driving ability? So we're going to be looking at 20 adults with chronic heart disease and partner controls, and we'll be doing cognitive testing to see how they score on paper tests. And then, of course, we'll do the driving simulator, which will include a driving component and testing component. So I'm going to stop here and pass it off to Dr. Thomas.
All right, so thank you so much, Dr. Knoefel. And just a reminder, there is going to be a question and answer at the very end of this presentation. All right, but if you have any question, you can type on the Q&A box or the chat box at the bottom of your screen. So continuing with our presentation, so we're very happy to have our next speaker. He is Dr. Neil Thomas. Dr. Thomas is a neurologist at Bruyère Memory Program, Bruyère Continuing Care, an affiliate investigator at Bruyère Research Institute, and also an assistant professor at the Department of Medicine at the University of Ottawa. Dr. Neil Thomas will talk about home monitoring technologies that aim to detect functional changes in individuals with cognitive impairment and to develop a French adaptation of the memory support system, which is an evidence-based intervention that trains persons with mild cognitive impairment to complete personal goals. And I will turn over to Dr. Thomas.
Hi. All right. Well, thanks for inviting me to talk about my research. Oh, perfect. Okay. So I was just going to ask about that. So we have a shared screen, so I can now access that. So that's great. So as Ramon said, I'm going to be talking a little bit about new ways that we're looking at evaluating individuals with cognitive impairment and looking to help them and their care partners. So the traditional way that we assess people is in the clinic, and we ask people to come in, we get information from them, which is from self-report. We ask people to think back to everything that's happened over the last few months and try to give us a picture of what's going on. The assessment's done in the clinic, which is convenient for me, but not for other people coming here, especially if you try to park at Bruyère. We have infrequent and episodic assessments. So you come to the clinic every few months and we check up and how things are going. We ask some questions, we do some tests that are, try to get an idea of what's happening in someone's day-to-day functioning, but it's not a direct measure of what's going on. And the cognitive tests we do, they're quite important, they're quite valid, but they are somewhat artificial. And by that, I mean, it's not necessarily directly reflecting what you're doing day to day. And it may change a little bit depending on, how comfortable and how experienced the person that's doing the testing is. So again, we're looking at new ways, and we feel that if we're able to move some of this assessment into the home, we might be able to get different types of data that could be beneficial in certain situations. So some of this, we're going to get objective data and real-time data, and that means we're getting information of what's happening in the home. This is measured by sensors and different technology instead of the person trying to remember back to what's happened. It's continuous, meaning these information, like Dr. Knoefel showed with that wandering detection system, we can run that type of system over a longer period of time. The idea of ecologically valid is that maybe it's a little bit more measuring, things that you're doing day to day and not just asking you to remember a list of words or different things like that. The idea with a lot of the sensors and the platforms that we use is that it's unobtrusive, meaning it can just sort of fade into the background, and the person is able to live their life, and we are able to collect information, find out what's going on. We can also assess what we call intra-individual variation. So we can compare one person to themselves, not to a large group of people who we think are similar to them because of their similar age and physical status and things like that. And then if we get high frequency data collection, instead of me getting a bit of information every 6 months, we can look about changes that are happening day by day. And so this gives us an idea of why, being able to measure you against yourself might be important. So generally, when we do studies and research, we will compare someone to a group of people that are matched, again, usually based on age, maybe education level, other medical conditions. But when we're looking at something like this, is a measure of gait speed, so how fast someone's walking. And so this is measuring how many walks that happened in the home using a home sensor that's measuring speed of walking and then how quickly they walked. And so you can see if we compared subject A and subject B into a large group of people, subject A might seem like they're quite slow, or there might be a problem with their walking compared to subject B, who's almost twice as fast. But if this is sort of the normal walking speed for subject A, and it's not the sign of any problem, the better thing is for us to measure that, and then we can, over time, compare that person to themselves, and then only kind of start to do assessments or get worried about if something is dropping below that person's normal level, and we can kind of look to see when they're going to be doing things less than what's common for them. So The other thing that might be helpful with this idea of high frequency and continuous data is that, again, when we're assessing people in the clinic, we're going to see, so this is just a measure of, let's say, a hypothetical measure of someone going through and developing dementia. So there's a slow progression over time. Maybe their functioning is normal early on. They might have early changes, mild cognitive impairment, eventually to dementia. This is what we sort of look at, just a general marker of brain health and reserve and cognitive functioning. And then this would be a clinical marker. So this could be, a pen and paper memory test, or looking at walking speed, looking at medication adherence. And what a lot of this data of looking at home-based monitoring has found is that before, maybe we see the person in the clinic at this stage when there's a lower period of functioning. But before that, there might not have been a big change in their day-to-day functioning that was measurable, but things might become more variable. So instead of, starting to completely forget to take medications, maybe, you miss that dose and you take it a little bit later in the day. So there's sometimes, again, this variability that can be a sign of cognitive decline or changes in memory and thinking, and that is happening before there's a noticeable or measurable change that the family or the person might see. So the idea here is, these types of assessments, we might be able to pick up things a bit earlier and see when that variability is happening, and then either make it intervene a bit earlier in people who are developing changes in either cognition or other aspects of their health. So with that in the background of why there might be some benefits to home monitoring and home assessment, we're looking at a project that will look at smart home systems for individuals with cognitive impairment. So we want to look at testing and developing new methods to detect changes in day-to-day functioning in individuals in the home setting using this type of unobtrusive technology-based platform. And so the overall objectives will be to kind of review the sensors, and what we've been doing over the last couple of years is looking at a research-based platform, and we're partnering with a group that has a lot of experience with this, and a collab that we collaborated with in the US. We want to see if Canadian-based and the sensors that we're looking at could be looked at within this platform. We want to obtain feedback, so we want to get information from older adults, individuals with cognitive impairment, and their caregivers. And we've done some focus groups and information on this to find out, what are their priorities for data collection, how would they want to use the data, and how would they want to start to get feedback and maybe prompting from this type of system, and then start that actual ability to take sensor data, and instead of just look at it, down the road in a research study, can we start to provide immediate support or maybe some feedback to individuals, provide them information on what the sensors are telling us. So here's just a general overview of the research-based aging in place platform that we've been using. This is one of a few different sensor platforms we're looking at, but this is developed by, again, our collaborators in the US, and it's allowed us to share data and look at information from the system and compare it to studies that have already been done. So again, we're able to get information on mobility through the home and activity in the home with motion sensors. In some studies, when we have multiple individuals in the home, people may use a smartwatch. They can track activity level, step count, sleep. We get some information on body composition and weight. We have an electronic pill box that lets us know when the compartment's open and closed to better track medication taking behavior. We can get information on sleep with a pressure mat, similar to that the Dr. Knoefel showed you in the last study, measuring things such as computer activity, not what's exactly happening on the computer, more just computer use, like how much time, how many sessions, because that other studies have shown that changes as people are developing cognitive impairment. Again, that idea of that variability before a decline. And then information on contact sensors on the door to see time spent out of the home can be a marker of socialization. All of this is collecting information in the background. The person is just told to live your life as you normally would, and this sensors can pick up, again, these changes in day-to-day functioning and patterns of activity that might suggest there's changes in health. It's all collected by this monitorless PC and then sent to right now to a secure database where it can be studied for research studies going forward. Again, as I was saying, this is part of a large group of researchers who are looking at home-based monitoring, home-based technologies to support aging in place type research. And so we're one of this group that are using the same type of home assessment system. So here we get some actual data and information from the system. We can start to look at activity patterns, what's normal for an individual, and again, what might signal some changes in their health. So here we're looking at what we call a circle plot here. So each ring is 1 day, and we're getting information from the sensors. This plot is made up of data from the activity, the motion sensors in each room, and then also a smartwatch. So when there's activity in higher levels of activity in one or multiple rooms in the home, let's see these green dots. So there's lots of people, or people are moving through the home a lot during the day. Same thing at night, we can see the levels of activity that sort of finish off around 11 or 12. Periods of black, these little black dots are when there's not really activity in the house. And then the blue here is the sleep period as measured by the watch. And so this is an activity pattern of an individual with mild cognitive impairment living with their partner. And again, this is just an example of what sort of data we could get to form a baseline of activity, and then see, are there changes? Is sleep periods becoming shorter? Are they shifting if someone's not falling asleep as well? And what would be changes in the pattern of activity over time? We can also measure things like medication adherence. And this is data from almost a whole year from an individual who developed dementia during the study monitoring period. So this is just the time of day here. And we're seeing when the pill was taken. And this is the date of monitoring over again, almost a full year period. Each black dot here is when a pill was taken and the time it was taken that day when that compartment was opened, and then the X is a day that the pill was missed. And so again, over that year period of time, we can start to see trends where, maybe there's a bit more variability. The pills are being taken at a bit more erratic times, and later on in the monitoring period as the person's condition has progressed, and they're also missing doses a little bit more frequently. One method that might be helpful is to start combining information, because that can give us more information on what's going on in the home. And the reason I show this type of example is here we have just, again, a representative example from data from one home where there's information from passive infrared sensors. So these sense motion in each room, so we can tell where someone is in the home. The wristwatch is just measuring whether the person is asleep or awake. And then the bed mat is giving us a bit more fine detailed information about sleep. And so you can see what this picked up was that there was the person got out of bed at some point. And by combining information from these sensors, we might get a little bit more information. See, you can see how the wristwatch didn't really pick that up, but the bed mat did. And then we can get a bit of information about what happened. So, someone who might be getting up at night, are they wandering around the home? Are they having difficulty going back to sleep? Or was it simply just a quick trip to the bathroom and then back to bed? And so the overall idea is to, again, to create this sort of supportive smart home system. And this is a model of what we'd like to do with our SAM3 group that Dr. Knoefel talked about, being able to monitor multiple different activities in the home to see if there's day-to-day changes in functioning that are important to people that signal changes in health, provide that information, start to be able to do an analysis and provide that information back to individuals. And one of the ways we're doing that is to look at creating a feedback system. So here, again, we have some data from the watch on the right panel here, the step count for the day, and then the sleep period, and an average sleep period over the last few weeks. And then information on how much time is spent together and time in different rooms in the home. And so from our focus groups and the work we did to find out what older adults wanted in this information, people were able to let us know that this sort of system they felt would be helpful. It'd be allow them to get some insight into the person living with dementia and their sleep targets. If they see something that's wrong, they might, go to find further investigation. They indicated, some of this could be upsetting at first to see if there's changes, but it would be eye-opening, good to know, because you could take action on that. And a lot of people wanted something in a summary weekly. So based on that, so we do have a daily summary, but then we also are providing information in a sort of weekly summary. And we're also looking at providing a weekly summary that analyzes the data a little bit and tells people, your sleep was not as good this week compared to last week, or, your activity level either went down or up a lot. And so we get these weekly summaries of sleep, of step counts, and then also of time spent together. And so we're recruiting right now to test this type of system. We want to get information back from people about what they think of the system. Is it the information useful? Can they understand it? And so we are looking at caregivers and former caregivers of individuals with cognitive impairment to look at the system for a 4-week duration. They have access to simulated data and be able to sort of give us feedback on this type of feedback system. And then, we do want to look at other ways. Can we do better assessments of nighttime behavior, like the wandering detection assessment that Dr. Knoefel talked about, maybe looking at people who are seen at Bruyère in different programs like the day hospital or geriatric rehab, be able to follow them afterwards. So the second part that I want to talk about is a support system for individuals with mild cognitive impairment. So the HABIT program was designed at the Mayo Clinic, and we're partnering with collaborators there to look at this a component of this HABIT program. So this is something that is trying to help individuals with mild cognitive impairment learn the best skills for helping to maintain independence and function. Normally it consists of 5 programs. So there's 5 components. There's a memory support system that does some training that I'll talk about, the cognitive exercises with online computerized cognitive training, exercise with yoga, support groups, and then information sessions to promote wellness and information on mild cognitive impairment. But the part of that we're focusing on is this memory support system. So this is a 2-page per day pocket-sized calendar note-taking system, and it breaks things down into events, to-dos, and then journaling for helping to log important information for people to help remember what's coming up and what's going on. This training session consists of 10 1-hour sessions, and it's delivered to the individual with cognitive impairment and their partner. And the idea is to help support independence. So right now, this is offered in English in the Mayo Clinic systems, but as we have a bilingual city in it, we're in a bilingual area of the country with it. We want to be able to offer this to francophones as well. So we're looking to translate and culturally adapt this memory support system into French and be able to provide it to francophones with mild cognitive impairment and their care partners. And so this study would be looking at the adherence. Do people, learn and be able to keep up with the intervention? And then does it have any benefits on their mood, quality of life, and the stress level of the care partner? So we are still recruiting. This is coming to a close near the end of this year, but we're looking for French-speaking individuals who have a diagnosis of mild cognitive impairment and have a care partner that they have contact with that would be willing to do these training sessions. And again, it's over 2 to 6 weeks and 10 hours each. They would do some testing before the assessment and fill out some questionnaires. They then go through the training session and then repeat some of that testing afterwards to see if there's any change or benefit to the intervention. And again, moving forward, we want to take this and be able to offer it to individuals seen at Bruyère and in our Ottawa community in both English and French to see, again, provide this memory support system as an intervention to help people with mild cognitive impairment. And eventually, we'd love to be able to implement that entire HABIT program in the Ottawa region as an intervention for people with mild cognitive impairment to provide additional support. So thank you for your time, and I'll pass this over to Dr. Frank.
Well, thank you so much, Dr. Thomas. So to continue our presentation, our next speaker is Dr. Andrew Frank. He is a cognitive and behavioral neurologist at Bruyère Memory Program. Dr. Frank will talk about updates on clinical trials in Alzheimer's disease, virtual reality, and GPS technology. And thank you, Dr. Frank, for joining us, and welcome to this presentation.
Thank you, Herman, and great to be with you this evening. Do I have control over the slides? Let's see. You can advance. So most of my work over the last 15 years at Bruyère, in addition to seeing patients, has been in being the site investigator for clinical trials testing new treatments for Alzheimer's disease. As we all know, the treatments that we have for Alzheimer's disease are insufficient. The burden or the challenges for individuals and their family is significant, and we are in desperate need of new treatments. And the clinical trials unit or clinical trials research unit at Bruyère has been doing clinical trials in the field of Alzheimer's disease for much longer than I've been at Bruyère, for over 25 years. And since I've been here, we've been involved in multiple phase 2 and phase 3, which are sort of final phase human clinical trials, testing medications for Alzheimer's disease in a double-blinded, meaning an individual does not know if they're on placebo or not. And even the care team, our team, does not know if an individual is on a placebo or not. Placebo-controlled, meaning that we are able to test a medication and try to control for the placebo effect. And this is considered sort of the highest level of evidence that we can collect to know if a medication is working or not. Because we really only want medications that are working to be available to the public one day. And we've tested multiple oral and intravenous treatments over the years. And as you may have heard in the news, certainly over the past number of years, that the vast majority of these trials have unfortunately been negative, meaning they have failed to show that these medications, which you see here, are any better than the placebo that they were tested against in a blinded and placebo-controlled fashion. And that has been very disappointing, of course, to all of the individuals who are affected by Alzheimer's disease, their families, of course, even our research team. It's been difficult to go through these failures one after another over these many years. It is obviously not for lack of trying. It is not even for lack of funding in a way, and that these trials are partnerships between our hospital and many hospitals around the world with pharmaceutical companies who have brought these new treatments forward. Again, hundreds of millions of dollars being invested in this condition for which the need is so great. And despite all of that, most, if not all of the ones you've seen here have failed over these 15 years. But yet the work continues. And the trials continue. In the sense that we can really never give up on the quest for new treatments for Alzheimer's, because the need is only increasing ever more with every year. As the population continues to age, the need for new treatments is even greater now than it's ever been, and will continue to increase over the next 10, 15, 20 years. And so the hope to find new treatments will never end, and the trials will continue until we find something, and hopefully more than one success over time. So at this moment, we are still involved in clinical trials testing what are called anti-amyloid antibodies. You see a couple of strange names there, aducanumab, donanemab. These are intravenous treatments that are given intravenously every month and enter the brain and try to remove the amyloid protein from the brain, which we still believe is what is damaging the brain and causing the memory loss of Alzheimer's disease. So we are trying to, modify the disease. We're trying to slow the disease. If we can't cure the disease, we want to at least slow it down so that individuals can live a long life without ever having to develop the severe dementia, which is so debilitating to individuals and their families, to allow people to live a full life without having to really have their functioning robbed from them. And again, many of these anti-amyloid antibodies have failed in clinical trials, but yet they remain in clinical trials even to this day. And we can touch a little bit later, perhaps in the questions session, that there has been some news lately in some of the current anti-amyloid treatments that there may be some benefit. And we can touch on that a bit later, which again renews the hope that there will be success in clinical trials and that we'll have new treatments for Alzheimer's in the not too distant future. In addition to anti-amyloid antibody trials, we are involved in other clinical trials testing other medications which are not intravenous. We have some oral medications as well, which try to attack the disease from other angles. A sigma receptor agonist here tries to reduce oxidative stress in the brain cells and try to prevent them from being damaged or from dying, in fact, over time. A TREM2 agonist here stimulates microglia, which are cells in the brain which, if we can go back one, cells in the brain that can clear proteins for us, and that's an intravenous treatment. There you will see an OGA inhibitor, also an oral treatment, which actually tries to prevent a second protein in the brain called tau from aggregating. And we're also involved in transcranial infrared light therapy, which is believed that such light can travel through the skull and again stimulate clearance of proteins, because we still believe that Alzheimer's disease at its core is an accumulation of proteins in the brain, which starts to damage the brain. And so again, there is this great hope that one day we're going to find some either intravenous or oral treatments or both, which can significantly interfere with this biochemistry in the brain so that people can live a full life, even with these conditions present, that they can still live a full life without having to experience the worst symptoms of Alzheimer's or dementia. So moving beyond the clinical trials, which have been underway for so long, I'm also involved, like my colleagues who have spoken tonight, in terms of finding technologies which can help us with the condition while we wait for new treatments to be developed. For example, is it possible to develop a computerized memory test? And so for many years, we've been working on with the creators of this product, which is a computerized cognitive test in which there are playing cards shown on an iPad, where you simply have to press yes if you see a red card and no if it's a black card. Press yes if you've seen the card before in the series that are being shown, and press yes if it is the same card that was just shown before. So essentially, on an iPad, it's a computerized memory test that flips cards and requires you to try to remember if you've seen the card before, the goal being to finding a more sensitive test for memory loss. Because yes, we use paper-based tests, as we mentioned before, but what if there are more specific or sensitive tests that can be done on a computer like this one, which can actually detect memory loss earlier, more reliably than the traditional paper-based tests that we've been using for decades? We'd love it if the computer can predict that earlier. So next slide. If we just look at the test, have you seen this card before? You can really sense that that might test short-term memory. Here we showed in an early analysis that those individuals who were destined to get worse with their memory seem to also be getting worse with that particular card game of, have you seen this card before? Now, we are still collecting data on this trial, and we hope to have much more data over a much longer period of time to see if this task, have you seen this card before, yes or no, can predict people's decline years in advance, possibly 2 or 3 years in advance. That's what we want the most, something that any one of us could try on an iPad to try to predict the future, telling us 2 or 3 years in advance if we are destined to get worse with our memory. And we're hoping that a computer technology can do that. We are working on virtual reality. If you've never heard of this before, it's a kind of technology where you wear a computer screen on your face, where there's a screen in front of you, where there are speakers that are playing voice or music into your ear, and even microphones in the goggle to try to hear what you're saying. So by wearing these goggles, you are basically immersed in a virtual environment around you. For individuals in long-term care, nursing home, there can be significant social isolation, especially during the pandemic. So is it possible to wear a goggle such as this to place you in a new environment, like sitting at a beach, for example, and hearing the waves, or in a forest and hearing the birds? All of that is possible, and work has been done to show that many people enjoy such immersive experiences, and that this may decrease the sense of isolation being in a nursing home. we would like to take this one step further and are trying to develop what's called a virtual companion. That is, this lady who we've named Kira is a computer-generated companion that is presented in the virtual reality goggles to try to provide a source of socialization and companionship to individuals who are in long-term care. This virtual companion can hear what is being said by an individual through microphones in the goggles, and can then speak back to an individual through speakers in the goggles, and can potentially carry on a conversation so that this her name Kira can ask questions of an individual, try to elicit conversation and reminiscences, and then provide feedback as part of conversation to the individual. We're looking very closely into what's called artificial intelligence conversation generation, where a computer can try to understand what is being said by a person and try to generate appropriate responses to try to keep the conversation going. Our dream, of course, is to have this application in long-term care so that those individuals who are isolated will have someone to speak to. This doesn't, of course, replace a real person, but this may provide another source of socialization that could improve quality of life. We are looking into GPS technology. As we know, those individuals with dementia can wander from their home, and this can become very hazardous to their health, especially if it's nighttime or wintertime or both, in the sense that some individuals may become lost outside at night or in the winter, where their health may be compromised, and this could well be fatal, as it has been in some individuals who have wandered from their home. Many of these trackers have a very limited battery life of just 3 to 5 days. Like our phone, they have GPS tracking, but they need to be charged every few days. And this may not be a successful solution, because a device such as this may be being charged and not being worn at a time when a person needs it most, when they wander from their home. So we have set out to find a GPS tracker which has a much longer battery life. And so an alternate low-power GPS system was unveiled by Apple, the maker of the iPhone, in 2021, in which it is possible to track individuals in the community using low-power, non-GPS technology through Bluetooth connections. And I know that some of these technological terms may not be familiar to everyone, but it is possible to use this new Bluetooth system unveiled by Apple last year to track individuals in the community through Bluetooth or low power connections anonymously by other strangers in the community who have iPhones. So as long as using this system, as long as an individual is near an iPhone, they can be tracked anonymously through other people's phones. Amazingly, in a private manner. So even though information is being used through other people's phones, there is no actual loss of privacy. And it is our hope to try to incorporate this technology with traditional GPS technology to try to lower the power requirements for a GPS tracker in the community, so that it may be possible using this technology to extend a battery life of a tracker from just days to possibly months. And we are also working on a design to have this tracker on a person's wrist at all times. Since the battery life is so long, we hope to have a wrist device which keeps this device on an individual at all times, even when they're being bathed, with a waterproof design, so that this could be on a person at all times, especially when they need it most, when they are wandering, even if it's nighttime, and that it may only need to be charged every few months. That means it's there on the person when they need it most, and we hope that not only will this improve quality of life, but this may save lives as well. And again, we're thankful for our collaborations. As you've seen with my colleagues tonight, there is a massive amount of collaboration with our partners, such as Carleton University, to actually design and create this technology. And we are, in fact, collaborating with the University of Ottawa as well for a microbiome project. This will be my last project to present to you, which is actually looking at the microbiome. If you've never heard of that, it's the bacteria which live in our bowels, which of course help with digestion. But more than that, they actually release transmitters that enter the bloodstream and may travel all the way to the brain and create a link, if you will, between the gut and the brain, promoting not only bowel health, but also brain health as well. All mediated by bacteria that are living in our bowels, which are in fact very helpful and do not represent an infection, but rather an essential part of our body. This project looks at what are called prebiotics. Now, you may have heard of probiotics. That's where we eat more of the bacteria, like in yogurt, to actually replenish the bacteria in our bowels. And that is very normal. Prebiotics are a little different. These are sort of foods that are eaten by the bacteria in our bowels. So a prebiotic, if we eat that, are not digestible to us, and they're not bacteria, but they are foods that eventually reach our bowels and actually feed the bacteria that are there. In doing so, we try to promote the bacteria in our bowels that we want the most, and try to discourage the growth of the bacteria in our bowels that we don't want, that are not helpful. So in this way, we're trying to manipulate and encourage a healthy microbiome. And in doing so, is it possible that having a healthier microbiome that we are able to encourage, could this actually help brain health? Could this actually help memory? So this project, which aims to recruit 40 individuals with mild cognitive impairment or mild dementia due to Alzheimer's, we are going with our partners at University of Ottawa. We are going to screen a stool sample to determine what their microbiome is currently. And then from that, we will determine the optimal prebiotic that they need to encourage the growth that we are hypothesizing will be beneficial to them. This individual will then receive either this prebiotic orally by mouth or a placebo, once again in this double-blinded placebo-controlled fashion. Just as I described for the clinical trials that we're doing, once again, this is the only true way to determine if an intervention is helping to overcome the placebo effect, to give an individual the active treatment or a placebo such that they do not know if they're getting the active or the placebo, and even our care team will not know, meaning double-blinded, if they've got the active treatment or placebo. So in that way, to prevent any sort of bias in both the participant and in our team, to try to get the most accurate determination of is this treatment, be it a clinical trial or a prebiotic, does it actually help? Over 3 months in this case. Next slide. To see if over 3 months they improve their memory. If they stabilize their memory, if they have any adverse effects in terms of their bowel habits. And yes, we'll be measuring the stool sample once again, which I know does not sound pleasant, but it is part of this study to measure the stool sample at the beginning and at the end to see if this prebiotic food for the bacteria will alter the bacteria and help memory. Thank you so much for listening to all of our presentations. I think we have Nadine on the line as well, who can speak more to our clinical trials unit, as I mentioned, involved in drug trials and technology trials. You've heard all about them tonight, and we are immensely thankful to all of the families and participants who have been part of our research over these so many years of so many different research platforms, as you've heard, and because we appreciate that it takes time to do the memory testing, to do brain scans, to take medications orally, to be given medications intravenously, to be part of technology studies with sensors and driving simulators, and memory techniques. All of that we know that takes time, and we are tremendously thankful for everyone's participation. And our dream, as you've heard tonight, is to find interventions that really help and improve quality of life.
Thank you so much to the speakers today, Dr. Knoefel, Dr. Frank, and Dr. Thomas, for those really informative presentations. So we've now entered the Q&A period. So I see that we have already some questions in the Q&A box, but if you have a question that you would like to ask, feel free to type it into the Q&A box and then I can read it out loud for you. So I see a few questions asking if the webinar is recorded and will be available. So the webinar is currently being recorded and it will be available on our YouTube later. And I can put the link to the Dementia Society YouTube in the chat box for you guys. Someone is asking how she can get her stepmother registered into one of the studies. I think you guys mentioned a phone number at the end. Should they contact that number?
Hi. Hello, everyone. My name is Nadine. Dr. Frank mentioned that I'm a research coordinator with the Clinical Trials Research Unit. I'm also the recruitment coordinator. So I help people get into research studies that they're interested in. So yes, so on that last slide, that phone number or email address, you just contact that number, you'd be speaking with me, and then I sort of help guide you through the process to get you into the various research studies. I would also explain that we have different types of studies, so drug trials, the technology studies, observational studies, and sometimes a retrospective study. So I'll go through all that information with you, and then you sort of pick and choose which ones you want to be what we call pre-screen for. So we would get you part of a registry, actually, where we could just pre-screen interested individuals over time for however long they're interested and sort of match them to studies as more and more studies prop up. So basically the investigators of Bruyère Research Institute come to the registry, they say, we have this new study, this is XYZ criteria, who would be interested? And we sort of just kind of call the people, let them know we have a new study, are you interested? And then you say yes or no. So yes, you would contact that number and then we'd walk you through the process.
Someone is asking if people with AD already see people and things that are not real, is it a good idea to expose them to a virtual reality? Wouldn't it be better to stick to communicating with people just around them?
Oh, yes. Nothing is more important than actual human interaction. This project sort of came out of partly the pandemic, and the unbelievable isolation that we all felt, and especially in long-term care with the lockdowns. It's just a technological determination. If the technology which is coming out today in terms of virtual reality and artificial intelligence, is there any way that could be turned into an intervention which really does help some people? It will not be for everyone. Of course, if someone has hallucinations or if someone can't tolerate the virtual reality, it is not for everyone. But if this technology could help some people, that would be really, really wonderful.
We have one question about sleep patterns. If they live with their partner but do not sleep in the same bed with them, does that impact sleep in some way as well?
Maybe I can start and then I'll pass it off to you, Neil. So I guess this is referring back to the project with the sensors in the bed and the nighttime disturbance and that kind of thing. So I'll say it's a kind of a double-edged sword, right? So if you're sleeping in separate rooms, the advantage is then you don't hear every time the person gets out of bed. So you can sleep through that part, right? So they go get out of bed, they they go to the bathroom, they go back to bed, and then you don't have to worry about that at all. On the other side, the downside is that if they do get up and then leave the room and then wander, to the front door and then walk out in the middle of winter, you have no way of knowing. So that might be even more nerve-wracking, because now you don't even know when they're leaving the bed or when they're walking around the house. So our technology has the ability to adapt to both those situations. So if you're in the bed and you want to sleep well, we say, ignore everything that happens around you, stay asleep, and then we'll wake you if you need to be woken. Similarly, if you're in a separate room, we can do the same thing. If you want to know when they get out of bed, we can notify you about that. But if you'd only want to be notified when they head towards the front door, we can notify you about that as well. So yeah, it's complicated. Neil, did you want to add something?
Yeah, so I'll just add a little bit. I mean, that's speaking to that sort of wandering detection type system that could be really important for some people. I think this technology also has some promise to potentially, be able to be used eventually to monitor changes like when we're initiating a treatment and seeing how people respond to an intervention. So there, we need to know, it would be important to know if someone's sleeping together or not. I can think of situations if people are in the same bed and the person with dementia or cognitive impairment has more disturbed sleep, that could definitely impact their care partner if they're getting up all the time and, disrupting the other person's sleep. With some of this technology, by being able to monitor sleep in both individuals, that is something we could technically potentially pick up. And the interesting part there would be, let's say a medication is started to help with sleep. Not only could you then monitor the sleep in the person given the medication to say, okay, now they slept for 6 hours straight instead of being up 5 times during that period. And we could also potentially get some information on the bed partner to see if their sleep is now more consistent as well. And from the situation where people are in different rooms, if we're trying to evaluate a medication there, obviously if you're not in the same room with the person, you might not know as well what's happening during the night, right? Unless they get up, wander around, make a lot of noise, we don't know if that medication is effective or not. So this is where some of the technologies can come in. And again, testing things, we get objective knowledge of when the person's in and out of bed. We get it over multiple nights to see if there's a pattern that's assessed. And then, the idea is you could get a baseline of how someone's sleeping normally. And then we could try a new treatment like a medication, and that might give more information for the individual, but also for their care providers and their healthcare professionals to make a decision to say, yeah, that really worked, or no, we got to try something new.
We have a couple questions about the news coming out about a drug that may potentially help with dementia and Alzheimer's. So Dr. Frank, if you could speak more to that, and also answer whether Bruyère is involved in those trials with those medications.
Yes, thank you for asking that. There was a bit of news in Alzheimer's disease last week in that results were released which indicated that one of the anti-amyloid antibodies, sort of like the ones I described in my presentation, these are intravenous treatments that release an antibody which we usually use to fight off infections. In this case, this antibody is targeted to enter the brain and stick to the amyloid protein that we believe is starting the cascade of brain injury in Alzheimer's. And so this treatment called lecanemab is an intravenous anti-amyloid antibody. It's given by intravenous every 2 weeks. And over a period of 18 months, it slowed the decline of memory by 27%. And that was different than the placebo. As I mentioned, we have to show that that's different than the placebo, which it was. Now, that perhaps isn't as high as we wanted. We would have wanted a 50% or 75% slowing of memory decline on this treatment. But it does represent one of the best results we've yet seen in any of these disease-modifying treatments in Alzheimer's for over 15 years. And that is, again, the disappointment which has happened in our field for so long, in that we have had no success for so long. This 27% difference does represent one of the best results yet seen for quite some time. And this might trigger applications to the United States and Europe, and yes, even Canada, to have this treatment available, even in Canada. Now, the timeline for that, once again, is long. It may be well over a year before we're able to use that treatment. But, and of course, we'll be watching these developments very, very closely. But over the next year, we will get a sense of whether or not this treatment has shown enough benefit to have it approved in the United States, in Europe, and maybe even Canada, such that we could start to offer a treatment like that over the next 2 or 3 years, intravenously, to try to slow the progression of Alzheimer's disease. And the hope is that such a treatment could be started early, before the brain damage occurs, and if taken, could it sort of extend the life that we can live without experiencing the worst symptoms of dementia. Now, I cannot guarantee that. The trial was just 18 months long, and so we don't really know its effect beyond a year and a half. But such data is being collected. And so in the end, it represented a hopeful piece of news that this kind of treatment could help, that might be available over the next year or two, maybe even in Canada, and that if it becomes available, we want our clinic hopes to be part of the infrastructure to start bringing it to the public, and that is something that that could come out of Bruyère in our region, because we've been doing, as you say, these trials for so many years, and have been not part of that one particular trial of lecanemab, but many other trials just like it. So we hope to be able to bring that experience to hopefully bring a new treatment to the public.
Is there currently a way to monitor the quality of sleep? Danielle is saying that she's worried that her husband may not be sleeping soundly or may have sleep apnea. So are there current technologies that are available to the public for monitoring sleep?
Again, I think I'll start and then anyone else can jump in. So there are a number of technologies currently available. So you can get like just a Fitbit, and it will give you some idea about the quality of sleep that you have. There are devices that go beside the bed that sense your breathing and your movement in bed, that can do some kind of sleep analysis. And there are sensors that are attached to the bed that can sense your tossing and turning and use that information. And you saw one of those in my presentation earlier. So the short answer is yes, there are devices that can do this thing. The unfortunate thing, though, is that the quality of the analysis is not that good yet. So if anyone was crazy enough to wear a Fitbit and an Apple Watch and put a sensor under their bed, and then look at the results of their one night's sleep with those 3 different sensors, you'd think that they were 3 different people. The same night of sleep analyzed by 3 different devices, they don't even agree on the information. So unfortunately, the quality of the analysis isn't quite there yet for us to use. However, that's why we're doing the research, and we hope to continue to do that. And the idea, of course, is to use, for instance, a bed-based sensor to have an idea of the quality of sleep, then to intervene, and then to see later if that's improved. Now, for sleep apnea specifically, that requires currently a night in a sleep lab. So if you're worried about that, talk to your family physician. They will ask you some further questions and then can refer you to a sleep specialist. But yeah, currently a sleep apnea diagnosis requires a sleep lab.
Concerning the long battery GPS, is there any estimation about when would that be available to the public?
The development is still in early days, even with the virtual reality. The development is in early days. It would be wonderful to start developing these prototypes over the next 2 to 3 years, but I certainly could not guarantee anything available to the public before then.
Are you planning to expand your long-term care trials of these sensors and monitors to more locations?
Yeah, that's a great question. So, when you think about a project like this, there are always new questions to ask, and to answer these questions, we require partners and we require research funding. So it's a complicated process to get there, but we are always on the lookout for new partners, and we're always on the lookout for new funding opportunities, and we certainly will bring those together as we'll certainly continue to do this research, because we do think that sensors in the home, sensors in retirement homes, sensors in long-term care is part of the future of care. Yeah, so complicated answer, but yes, for sure, we're always looking for new partners.
I think this is a question for all of you. How can technology help people or patients with dementia who don't use technology or who aren't necessarily familiar with technology? Is there any barrier to using this technology if they're not familiar with it?
Do you want to start, Neil?
Yeah, sure. So I think, that's one of the reasons that if you looked at some of the information that Dr. Knoefel and I talked about is moving towards a lot of methods that are what we call unobtrusive, and don't really require the person themselves to know a lot about technology or interact significantly with the technology. The idea with a lot of these sensor systems that we've been looking at is that they can be put in somewhere, and the examples too in the retirement home and the transitional care unit are also great. Like, that's in places where we're not asking the person to learn how to use a new iPhone or a tablet or anything like that. The sensors just go into the background. We monitor and track different patterns and activity and different aspects of what the person's doing in their day-to-day life, and that will give us information. So yeah, I think the idea behind this is that we want to make it as sort of, most of it should be user friendly, and the burden of having the technology work is on the research team or the people putting in that information that are going to be collecting it, so you don't need to be learning new skills to be able to use some of these systems.
And I'll only add to that, the irony of this is that many of these sensors that are embedded into the room really require no action whatsoever, and they passively monitor the person with cognitive impairment. The irony is sometimes they locate these and they go, "What's this? This doesn't belong in my room," and then they'll pull it out of the wall or they'll put it in their drawer, and then of course then they don't work anymore because a motion sensor that's inside a drawer can't detect motion in the room. So sometimes even a passive sensor, you need to find ways of disguising it well enough so that it doesn't disturb the person living with cognitive impairment. That was a great question.
I would simply add that we always, of course, involve care partners, family members, and they can, of course, provide a huge bridge to an individual with cognitive impairment to accessing the benefits of technology.
Okay, I think that's all the time we have for today, but thank you everyone for tuning in, and thank you for the wonderful presentations and for answering all the questions today. Again, you can watch the webinar on the YouTube channel. It will be posted later on there. And for more information on education, programs, and support, you can visit our website, dementiahelp.ca, or you can register to our weekly roundup. Have a nice evening, everyone.
Thank you, everyone.
Bye.
Thank you,
Thank
Dr.
you.
Park,
Thank you very
Knoefel,
much.
and Thomas.
Thank you.